Okay, so let's get started. Now, before going into learning a computer language like C or C++, let us first understand how we learned English. When we started learning English in our preliminary schools, how did we proceed? We first learned about the concept of alphabets. We learned ABCD. Then we learned words, dog, cat, mat, etc. After that, we started learning the concepts of prepositions, pronouns, and verbs, adverbs, and we learned how we can connect the words to form a sentence. After forming the sentences, after learning how to form sentences, we looked forward to developing paragraphs on a particular topic. So that is the stages that we need to follow in order to learn the English language. Similarly, when we try to learn the language C, we need to first learn about the tokens or the units of the language. Now, the unit of the C programming language are again alphabets, digits, and special symbols. After learning about these, we will look forward to learn about the concept of constants, variables, and keywords. Then we will learn how to give instructions and how we can string the instructions together to form a program. The C character set consists of alphabets, digits, and special symbols used to represent information. By alphabets, we mean uppercase A to Z and lowercase a to z. Digits involve 0 to 9, and special symbols involve all other symbols that are there in our keyboard. Alphabets, digits, and special symbols, when combined properly, are capable of forming constants, variables, and keywords. Now let us understand the concept of a constant and a variable. Constants are entities whose values never change, whereas variables' value can change. For example, let us consider a glass. A glass can hold water, milk, tea, coffee, etc. The content of the glass can change, but the property of water, property of tea, milk, coffee, they are not going to change. So in this case, it's the container or the glass who is acting as a variable, whereas the contents, that is the tea, coffee, water, or milk, they are the constants. Coming to the concept of computers, here we can have a variable by the name x assigned to it. Initially, we can store the value 3 in the variable x, but later on we can overwrite the value 3 with another value, say 5. Initially, the value of x will be 3. After the overwriting, the value of x will be 5. So in this case, 3, 5, they are both constants, whereas x is the variable. Keywords are special words which are used in the programming language or while setting the instructions and has got specific meanings for the compiler. Gradually, as we proceed with the learning of the language, we will come across these keywords now and then, and when we come across them, we will try to understand how exactly they work or what they imply to the compiler. C programming language has got these 32 keywords. Coming to the constants in C, the C programming language supports quite a few different kind of constants. There may be integer constant, there may be character constant, there may be floating point constant. Sometimes we also use a double precision floating point constant known as a double. We also have array constants and structure constants. To construct an integer constant, it must have at least one digit and there should not be any decimal point. The number can be either positive or negative. By default, if there are no sign preceding the constant, then it is assumed to be positive. Within the number, no comma or blanks are allowed. The allowable range for the integer constants ranges from -214748368 to 214748367. How do we get this value? Basically, an integer in a 32-bit machine takes 4 bytes of space. And by 4 bytes, we mean 8 into 4, that is 32 bits. Each bit is capable of holding 2 information or 2 bits. Each bit is capable of holding either 0 or 1, that is, two values. Therefore, the range of the integer is going to range from 2 to the power of 32 to minus 2 to the power of 32 plus 1. Note that the range of the integer constant will again depend upon the compiler. If it is a 16-bit compiler like the Turbo C, in such a case, the integer is going to be assigned 2 bytes of space, whereas in case of 32-bit compilers, the integer is assigned 4 bytes of space. So the range of the integer is going to depend upon the compiler. Examples of integer constants are like 1, 2, 3, 4, plus 6, 7, 8, 9, minus 5000, etc. If we want to look forward how to construct a real constant, there are also certain rules associated with it. Real constants are also known as floating point constants. Usually they are written in two forms, either the fractional form or the exponential form. In the fractional form, the real constant must have at least one digit and it must have a decimal point. It can either be positive or negative. By default, the sign is positive. If nothing is given, that means it's positive. Again, just like integer constants, no comma or blanks are allowed within a real constant. Examples are plus 1234.56, 6789.0, minus 5000.89, etc. Coming to the exponential form of representation, we usually go for this kind of form when the constant is either too large or too small. It has got two parts, the mantissa and the exponent. For example, 0.000123 can be written as 1.23 e to the power of minus 4. In normal arithmetic, it is basically 1.23 into 10 to the power of minus 4. The mantissa and the exponent is separated by the letter E in uppercase or in lowercase. Both mantissa as well as the exponent may have a positive or a negative sign. By default, the sign is always positive. The range of the real constant expressed in exponential form ranges from minus 3.4 e to the power of 38 or e38 to 3.4 e38. Examples of constants of this form are plus 3.2 e minus 5, 4.1 e8, minus 3.2 e minus 5, etc. Coming to the character constants. A character constant is a single alphabet or a single digit or a single special symbol enclosed within single inverted commas. Both the inverted commas should always point to the left. For example, as you can see, A here, which has got a starting quotation at the beginning and an ending quotation at the end, but both the quotations are pointing towards the left, is going to be a valid character, whereas A, where the first open quotation is pointing towards right and the ending quotation is pointing towards left, will not be considered a character constant. Coming to the data types can be categorized into three broad categories. The primary category or the first category is the primitive data type, also known as the basic data types. They are int, char, float, double, and void. Derived data types are formed by combination of qualifiers along with the primitive data types. And the third category, that is the user-defined data types, are formed by combining these primitive data types in structures, unions, and enumerator. When we talk about qualifiers, there can be two types of qualifiers, namely the size qualifier and the sign qualifier. The size qualifier can be long or short, whereas the sign qualifier can be signed or unsigned. The size qualifier increases the size of the primitive data types in case more space is required or less space is required. The size of the data types in the 32-bit C compiler is somewhat like this. Coming to the variable. Variables can be of various types, but a particular type of variable can hold only the same type of constant. For example, an integer variable can hold only an integer constant. Real variables can hold only real constants, and character variables can hold only a character constant. This is a simple representation of what variables can store. But ideally, a variable can store a value which is of size or which requires size less than itself. For example, a floating point variable is always bigger in size compared to that of an integer variable. Hence, a floating point variable can hold an integer constant. It can also hold a character constant. However, a character variable takes only one byte of space. Hence, it will not be capable of holding an integer or a floating point constant. Similarly, an integer variable is capable of holding a character, but it will not be capable of holding a floating point number. When we construct the variable name, it has to be a combination of 1 to 31 alphabets, considering both the uppercase and the lowercase, digits, and or underscores. Some compilers allow variables whose name can go up to 247 characters. While constructing the name of a variable, we should avoid creating unnecessarily long variables because it is going to add to our because it is us as a programmer who has to keep on typing those variable names while writing the code. The first character of the variable name must be an alphabet or an underscore. It cannot be a digit. Within the variable name, no comma or blanks will be allowed. There will be no special symbol other than an underscore in the variable name. We should always give meaningful names as variable names so that even after we revisit the program after quite some time, we can easily understand what each and every individual variable is doing or what is the purpose of the particular variable. Example, for storing the date of birth, we can either write DOB or date underscore of underscore birth. For storing the basic pay, we can write basic underscore pay 123 or something like that. Ideally, we should be following the Hungarian notation for giving proper names to the variables. Hungarian notation says that the first alphabet or the first character of the variable name should be the representing the type of the data that the variable can hold. For example, an integer variable should always start with I, a floating point variable should always start with F, a character variable should always start with CH, and so on and so forth. After the first few characters, which represents the type of the data that will be stored in the variable, we need to give a meaningful name to the variable. For example, if we want to store the, say, for example, the principal or the rate of interest and the number of years in case of a calculation of a program or in case of a program which is calculating the simple interest. In such a case, we can write I print for Hungarian notation, I ROI or F ROI for rate of interest, which can be a floating point number, and again I NOY for the number of years, which can again be an integer. Even if we skip the first few alphabets or first few characters where we are specifying the type of data the variable is holding, simply writing meaningful names like print, ROI or NOY to represent principal, rate of interest and number of years will also make our job much more easier.